Welcome to the next session. So in the previous session we were discussing the miscellaneous water treatments. Up to distillation part we have covered, and rest of the miscellaneous water treatments which are necessary to the water. So let us discuss them one by one. Okay. So next one is removal of iron and manganese. Removal of iron and manganese. Removal of iron and manganese. Iron and manganese. So removal of iron and manganese. So iron and manganese may present with or without organic matter. Generally this iron and manganese, it may be present like ions in ionic form, or they may present along with the organic matter. Okay. So iron and manganese, they may present in water either in ionic form, or in combination with organic matter. So if they are present in ionic form, it is easy for us to remove. So if they are present in ionic form like Fe2 plus, Mn2 plus, then they can be easily removed by aeration, sedimentation or filtration, anything we can use. So if they are in combination with organic matter, then we need to use either chlorine, potassium permanganate or lime. So we need to use disinfectants to remove the iron and manganese which is in combination with organic matter. Okay. So iron and manganese in ionic form can be easily removed by aeration, sedimentation and filtration, and in combination with organic matter can be removed by chlorine, Cl2, KMnO4, okay, Cl2, KMnO4 and lime, like that. So we need to use these kind of compounds to remove when it is in combination with organic matter. Okay. So likewise we remove the iron and manganese. Next is removal of hardness or water softening. Removal of hardness or water softening. Okay, so generally the hardness is of two types. We all know that hardness is of two types. hardness is two types. One is temporary, and the other one is permanent. And the other one is permanent. One is temporary and the other one is permanent hardness. So first let us see how to remove temporary hardness. So removal of temporary hardness. Removal of temporary hardness. Removal of temporary hardness. So temporary hardness is caused due to carbonates and bicarbonates of calcium and magnesium. Okay. So this removal can be done by simple boiling. So it can be done by simple boiling. By simple boiling we can do this. So when we boil the water which is having a temporary hardness, so let us take by boiling we can remove the temporary hardness caused by calcium. By simple boiling we can remove temporary hardness caused by lime, that is calcium, caused by calcium. Okay. So let us take this CaHCO3 twice. This is bicarbonate hardness of calcium. If we give energy to it, that means by heating, so we are giving energy to this. What happens to this? It will become CaCO3 H2O plus H2O and CO2. CO2 is a gas, it will go up. CaCO3 will become precipitate. CaCO3 will become precipitate. See, CaCO3 can be present like a precipitate. Okay. So it will be in insoluble form. CaCO3 will be in insoluble form when the pH is in between 9 to 9.5. When the pH is in between 9 to 9.5, it is in insoluble form. So whereas if the pH is less than 9, that is like 6 to 9 like that. So in this what happens? It will be in soluble form. That means soluble form. So if it is in soluble form, we cannot remove it. If it is in soluble form, we cannot remove it. So we need to make it insoluble. That is why generally up to the filtration part. So whatever the impurity, we see the total removal of the hardness. After that you will understand what is the importance of CaCO3 settlement. Once completely understood the temporary hardness and permanent hardness removal, once you look at the equations, once you look at the reactions that happens during this whole removal of hardness, you will understand the importance of CaCO3 and what is the importance of keeping the pH in between 9 to 9.5. So the thing is, when you keep it in 9 to 9.5, then this CaCO3 precipitate will be in insoluble form. So in insoluble form we can remove it. Because it can be settled like a precipitate. So that is what is the importance to keep the pH in between 9 to 9.5 up to the filtration. Okay, up to the filtration, so that it can be removed in the filter, and then disinfection process and recarbonation will take place. We will see what is the sequence of these operations and all. So let us go back to the reaction. So calcium bicarbonate can be removed by heating, by converting this into calcium carbonate, and this calcium carbonate again can be settled down when the pH is maintained in between 9 to 9.5. So in this way we can remove the bicarbonate hardness as well as carbonate hardness of calcium. If you look at the magnesium, hardness, so simple boiling cannot remove the temporary hardness due to magnesium. Okay, so here by simple boiling we can remove the temporary hardness caused by calcium, but we cannot remove temporary hardness caused by magnesium. So for that, first we need to convert this magnesium hardness into calcium hardness. For that we need to convert this magnesium hardness into calcium hardness. So to convert that, so we need to add to magnesium hardness with lime, hydrated lime, MgCO3 plus CaOH twice. So this is hydrated lime. This is hydrated lime. If you add hydrated lime to this, okay, this is hydrated or slaked lime. So if you use this hydrated or slaked lime, then it will form MgOH twice plus CaCO3. Again I told you CaCO3 is a precipitate and this is also a precipitate. If you remember this is also a precipitate. Okay, this is also a precipitate, MgOH twice, and CaCO3 is also a precipitate. And similarly, if it is MgHCO3 twice, okay, MgHCO3 twice, plus again here also we will add hydrated lime, then it will become CaHCO3 twice, sorry, CaOH twice, CaOH twice. So this will become MgOH twice and CaHCO3 twice. CaHCO3 twice. So now this CaHCO3 twice can be heated and that can be removed. It can be heated and that can be removed. Easily we know that. Okay. That can be removed. We already know that. It will become MgOH twice okay. So we can remove that bicarbonate easily. So this is how we remove the bicarbonate hardness and carbonate hardness of calcium, bicarbonate hardness and bicarbonate hardness of magnesium. So in this manner we remove the temporary hardness. So anyways, to remove the temporary hardness we need lime. Okay, simple lime is enough. Simple lime is enough to remove the temporary hardness. So temporary hardness removal needs lime. Okay, now this is done. So how to remove the temporary hardness, now we have learned. Come back. So removal of permanent hardness. So before moving into that removal of permanent hardness, one thing we need to understand here is to remove 1 mole of carbonate hardness of magnesium. To remove 1 mole of carbonate hardness of magnesium, we need 1 mole of lime. To remove 1 mole of carbonate hardness, we need 1 mole of lime. To remove 1 mole of bicarbonate hardness, okay, to remove 1 mole of bicarbonate hardness, we need actually 2 moles, because once this equation is formed, okay, once this one is formed, subsequent equation for this is, after this equation, what happens is, after this hydrated lime, this bicarbonate CaHCO3 twice reacts with lime again, excess lime, because whatever the excess lime which is present here, this lime will go and react with the calcium bicarbonate. and then it forms 2CaCO3, 2CaCO3 plus 2H2O. Because if it is directly CaHCO3, we can remove it by heating. But here CaHCO3 is forming along with magnesium hydroxide. So here CaHCO3 will be along with this, and whatever the excess slime which is present inside this water, so these two will get reacted again. And they forms 2CaCO3 and then 2H2O. So that is here the requirement of hydrated lime. If you look at this, the requirement of the hydrated lime is more in the case of magnesium bicarbonate. See, 1 mole of carbonate hardness of magnesium need 1 mole of CaOH twice. 1 mole of bicarbonate hardness of magnesium need 1 mole here and 1 mole here. So total 2 moles. Total 2 moles are needed. That is what is the thing we need to know. So 1 mole of MgCO3 needs 1 mole of CaOH twice or hydrated lime. But 1 mole of CaHCO3 needs 2 moles of lime. One mole of MgHCO3 twice needs, very important, 2 moles of hydrated lime. 2 moles of hydrated lime, that is CaOH twice. Okay, these are the things we need to remember. Okay, so 1 mole of CaCO3 does not need anything, but the simple boiling is enough for CaCO3 and CaHCO3. But here 1 mole need 1 mole, here 1 mole need 1 plus 1, 2 moles. Okay, so this is removal of temporary hardness. So let us go to the removal of permanent hardness. So, removal of permanent hardness. Removal of permanent hardness. Removal of permanent hardness. See how this permanent hardness is caused first. How this permanent hardness is caused. So, the permanent hardness is caused because of the ions calcium and magnesium and its ions such as Cl minus and SO4 2 minus. Importantly these are the cations, these are the anions. Okay, now so this removal of permanent hardness, there are many methods which are present here. Let us segregate them. What are the methods which are present? First one is lime soda method. First one is lime soda method, and second one is lime soda method, and the second one is base exchange or ion exchange. Okay, base exchange or ion exchange. Base exchange or ion exchange. And third one is demineralization. Demineralization. So these are the three methods generally we use to remove the permanent hardness. We use to remove the permanent hardness. Let us discuss the first method, that is lime soda method. Let us discuss the first method, that is lime soda method. Lime soda method. So in this method we use lime and soda both. We use lime and soda both to remove the permanent hardness. To remove the permanent hardness as well as temporary hardness, both can be removed at a time. So there won't be separate water which is having only permanent hardness. There won't be a separate water which is having temporary hardness. It won't be like that. In one water and same water, both temporary hardness may be present and permanent hardness may be present. So our removal process should be such that it should remove both temporary and permanent at a time. So though it is saying that it is permanent hardness, along with this permanent hardness, temporary hardness, if it is present, that should be also removed. Okay, that should be also removed. So we have already seen the lime reactions. What happens to lime when it reacts with calcium bicarbonate, magnesium bicarbonate and magnesium carbonate. All these three we have seen already. Those are nothing but the lime reactions. In this there will be lime reactions. So lime will be having a reactions. So the reactions with the lime, if it is temporary hardness, so these are the reactions. CaHCO3 twice. So we'll react with hydrated lime. And it will form 2CaCO3 plus 2H2O. Okay, and if it is magnesium bicarbonate, if it is reacting with lime, then this will become MgOH twice and CaHCO3 twice. And next MgCO3, it is reacted with CaOH twice. It will directly give CaCO3 plus MgOH twice. Okay, see, this is a precipitate, this is a precipitate, this is a precipitate, this is also a precipitate, and this will react again, come here. This will come here and react and form a precipitate. Okay, so if magnesium permanent hardness is present, so these are the lime reactions for temporary. These are the lime reactions for temporary. Okay, if permanent hardness is also present in the form of magnesium, so magnesium ions which are having Cl minus, SO4 2 minus and NO3 minus. So magnesium in any format, Cl minus, SO4 2 minus and NO3 minus. Okay, NO3 minus. So 2Cl minus, SO4 minus, 2 NO3 minus plus this lime. Okay, hydrated lime if we add, then it will become MgOH twice plus they will become the ions of calcium. So these ions will become the the magnesium permanent hardness will convert into calcium permanent hardness. So calcium permanent hardness, this will become calcium's permanent hardness. 2Cl minus, SO4 2 minus, and 2NO3 minus. So earlier this was a magnesium permanent hardness. Once it reacts with lime, it will become calcium's permanent hardness. Okay, calcium permanent hardness. So these are the reactions, and this lime also removes the dissolved gases. Okay, so this lime also removes the dissolved gases such as CO2. If CO2 is present, so this lime will form CaCO3 and H2O. Okay, so H2O and this CaCO3 gets separated. When CO2 is also present, that can also be removed in the form of calcium carbonate precipitate. Okay, so wherever I am showing this, that means it is able to removed. It can be removed. It can be removed. So this one cannot be removed. Still, it needs treatment. So these are the lime reactions. All the reactions which I have written here is all are lime reactions. The lime can remove the temporary hardness. Lime converts the magnesium's permanent hardness into calcium's permanent hardness, and also removes the magnesium in the form of a precipitate. Okay, and it can also remove the dissolved gases such as CO2 by reacting with that, and it forms calcium carbonate precipitate. These are the reactions. Okay, lime reactions. Now soda ash. So let us see the reactions of soda ash. See, everywhere if you see, one more thing we can derive here. So this already I have written, 1 mole of bicarbonate need 1 mole of lime, 1 mole of bicarbonate of magnesium needs 2 moles, 2 moles of lime, and 1 mole of magnesium carbonate needs 1 mole of lime. Here see, 1 mole of magnesium permanent hardness needs 1 mole of lime. Okay, listen carefully. 1 mole of magnesium's permanent hardness. Okay, magnesium's permanent hardness needs 1 mole of lime, 1 mole of CaOH twice. Why these are all important? Because how much lime is needed, we can calculate the quantity of lime needed to remove this hardness can be calculated when we know the relationship between the number of moles between these two compounds. So 1 mole of this needs 1 mole of this. Similarly, 1 mole of CO2 needs 1 mole of CaOH twice. So this relation if we know, so we can find how much quantity of lime is needed to remove some amount of concentration of hardness. Likewise, so to find that we need these relationships, right? Now next is soda ash reactions. Soda ash. So Na2CO3 reactions. So earlier the magnesium hardness is not yet removed. Magnesium hardness is converted into calcium hardness. Now the hardness which is left after lime treatment, okay, the hardness which is left over after treatment with lime. After treatment with lime is what? With lime is only calcium permanent hardness. Only permanent hardness permanent hardness due to calcium. So due to calcium. So all are removed because the magnesium permanent hardness is removed in the form of a precipitate, and that hardness is converted into the form of calcium. So in the water, temporary hardness is removed and the magnesium's permanent hardness is converted into calcium's permanent hardness. And now in water, what is present now? Only the permanent hardness due to what? Due to this Ca2 plus, due to this Ca2 plus. Okay. Now how to remove that? So Ca2 plus, so 2Cl minus, SO4 2 minus, and 2NO3 minus. So this will react with soda ash. This will react with soda ash. Okay. And it forms 2Na, these compounds. Cl minus, SO4 2 minus, okay, and 2NO3 minus. So it will form these compounds plus CaCO3 plus CaCO3. Now if you look at this, all the hardness, you can see all the reactions of the hardness. Finally the hardness is removed in the form of what? Calcium carbonate precipitate. So why I have told you in the beginning of explanation of removal of hardness, we need to maintain a pH of 9 to 9.5. So 9 to 9.5 pH is necessary to remove hardness. It is necessary to remove hardness because the CaCO3, all the hardness by lime soda process is being removed in the form of CaCO3 only. So CaCO3 will be in precipitate form in this range of pH. So to remove CaCO3, in turn removing the hardness is possible only when the pH is in between 9 to 9.5 range. Okay. Now, so if the pH value is less than the above said value, okay, if the pH range is less than the above said value, see one more problem here. The pH CaCO3 becomes insoluble when pH is in between 9 to 9.5, and also here one more precipitate is needed to understand, that is MgOH twice. So another precipitate is there, MgOH twice. So this MgOH twice will be in insoluble form, when pH is greater than 11. When pH is greater than 11, then this MgOH twice will be in insoluble form. Okay. So when the water which is having pH less than the above said value, that is 11 and 9 to 9.5, hence the PPT, what is the precipitate? Okay. Precipitate cannot settle. So that is why if the water is naturally not having this kind of pH, then we need to increase the pH by adding some kind of base. Such as lime. We again add lime, excess lime. We add excess lime in order to raise the pH. After these reactions also, if pH is not maintained, then we will add excess lime to raise the pH of the water. Okay. So again here one more thing, problem is complete removal of hardness is not possible. Because some amount, see, we are adding some lime. Okay, we are adding some lime to the water. Again this lime to increase the pH. So this lime will be increasing the pH, and it also forms a precipitate CaCO3. Okay, it also forms a precipitate CaCO3. Or else lime, if it is remaining like CaOH twice. I have added lime. Listen carefully. I have added lime, and lime is reacting with temporary hardness, lime is reacting with permanent hardness, lime is reacting with all the compounds present inside the water. And now lime is not finding any compound to react. So completely lime reactions are completed. So now if the pH is not at this range, then these compounds will not settle down. So now to increase the pH, we need extra lime which is in the form of molecular form. So it will remain in the molecular form and stay in the water just to raise the pH. And after some time, to distribute the water, so you have done with all the removal process. Now lime is remaining in the water. You want to remove that lime now. So to remove that lime, we need to do recarbonation. So we have to do recarbonation. So we need to bring down the pH again. You need to bring down the pH again to a normal level in order to make it fit for drinking. To do so, this free lime should be removed. This free lime will be removed again by sending CO2 through it. So now the pH is coming down as the CO2 is sending through this water. So it will form a precipitate. This lime will no more in the form of molecule, it will react with CO2 and it forms CaCO3. That CaCO3 may be in the precipitate form in the beginning, but the pH is reducing. So when the pH is reducing, what happens to this? It will again become soluble. So in this lime soda method, it is not possible to remove complete hardness. Because how can we remove complete hardness? So we need lime to raise the pH. If lime is present, again we need to bring the pH. So if while doing this, bringing down the pH, the lime will become again CaCO3 because we are sending CO2. So once it becomes lime and at a pH less than 9 or 6 to 8, because bringing down the pH means what? We are reducing it to a pH of 6 to 8, which is drinkable. So in that range, the CaCO3 will not be in insoluble form. So that means it will be completely insoluble form. That means still there is some hardness which is present inside the water even after the lime soda process. That is the hardness. So there will be residual hardness. Will be present in the water. So after all this process, we will be having up to 40 mg per liter hardness will present in the form of CaCO3. Hardness will present in form of CaCO3 because this cannot be completely removed. So that is why using lime soda process, okay, and about 10 up to 10 mg per liter of MgOH twice will also present. Okay, so up to 10 mg per liter of MgOH twice will also present. So complete removal is not at all possible. So using lime soda process, we cannot achieve zero hardness. Using lime soda process, zero hardness cannot be achieved. Okay, using lime soda process, zero hardness cannot be achieved. Very, very important. Okay. So likewise we do the lime soda process. And this whatever the hardness which is not removed in the lime soda process, so this will gets removed somewhere in the distribution system because of any reason. This CaOH twice or CaCO3 or MgOH, these are also they can also become precipitate. They can also become precipitate, but depending upon the conditions. If these two are becoming precipitates anywhere inside the pipe system, then they will reduce the pipe cross sectional area. Because if they are settling, they may not settle as CaCO3, it may settle in other form also, depending upon the availability of the metallic ions and availability of the ionic compounds present inside the water, which may enter after distribution system, after complete purification in the distribution system. Then if these compounds settles inside the distribution system, they may reduce the pipe cross sectional area, by which it is difficult for us to remove them, and pipe may also gets failed. Pipe may also gets failed because of this reduced cross sectional area. Now here after this lime soda process, heavy sludge will form. Lot of sludge will form. See, if you see everywhere, CaCO3 is the precipitate. Precipitate means what? Sludge. So if you look at all the reactions in this, so far we have seen for removing temporary and permanent. So everywhere it is being removed either by MgOH twice or by CaCO3. Majority is CaCO3. So all these precipitate is nothing but sludge. So the problem associated with lime soda process is, so heavy sludge will form. Disposal of sludge is a big issue. Disposal of this precipitate is difficult, because if you treat the same method, if we use for municipal water, so that means every day we will get some amount of sludge out of this method. So where do we dispose all that sludge? So disposing of sludge is a big issue, big problem in lime soda method. So let us see how this lime soda method sequential operations. What are the sequential operations that we perform in the lime soda process? Once we mix the lime soda in water, and then what we need to do after that process. So lime soda process, so we do mixing of lime soda with water. So mixing of lime soda and alum also we will add. So we three introduce into the water and we mix. That is the first process of lime soda method. After mixing, we will send into the flocculator. Flocculation. So after mixing, what happens? Flocculation happens. After flocculation, sedimentation. Sedimentation. Here in sedimentation tank, in this sedimentation tank, we will remove this alum, AlOH thrice, and MgOH twice, and CaCO3, all the precipitates which are forming out of these reactions. All the precipitates which are forming out of these reactions will be removed here. And in the same location, after sedimentation, some amount of lime and MgOH twice will remain in soluble form. Which remains in soluble form or may not be settled in the sedimentation, that here we will send into the filter. Here we will send them into filter. But before sending into filter, we need to do recarbonation here. So we need to do recarbonation here. See, before sending into filtration, we need to send CO2 in order to remove, first in order to make them precipitates like MgCO3. If any lime is present, CaOH twice is present in soluble form. So that CaOH twice, MgOH twice, that will be removed by recarbonation in filter. So though how much extent you try to remove, some amount will be present in the outgoing water. Okay, about 40 mg per liter as CaCO3 and 10 mg per liter as MgOH twice. Okay, so when we are using lime, then the dosage of alum will reduces, because lime is also a kind of agglomeration capacity it is also having. So that is why lime, if we add, the alum dosage will reduces, because lime is also a coagulant. If you remember, while discussing the coagulants, lime is also a type of coagulant. So if you are using one coagulant, other coagulant dosage may reduces. And also here during this process, what I told, pH is maintained above 11 or above 9. So when pH is maintained above 9, disinfection also takes place. Whatever the bacteria present inside the water or microorganisms present inside the water will killed by the pH. So as lime is also having coagulating property, coagulating nature, alum dosage can be reduced. And the other thing is, to remove CaCO3 and MgOH twice, we maintain pH above 9. Hence bacteria, whatever the microorganisms cannot survive. So disinfection also takes place in the lime soda process. And also it removes iron and manganese, small quantities of iron and manganese can also be removed here. Also gets removed. But the only drawback of this is heavy sludge is formed here. The main disadvantage of this method is it forms huge amount of sludge. It forms huge amount of sludge. Okay, so this is the drawback of lime soda process. And 1 mg per liter of calcium hardness. Okay, so here 1 mg per liter of removal of carbonate hardness of calcium. Okay, calcium hardness as CaCO3 produces 1 mg per liter of sludge. 1 mg per liter of sludge as CaCO3. Sludge as CaCO3. Similarly, 1 mg per liter of removal of magnesium hardness will produce magnesium hardness as CaCO3 produces 0.58 mg per liter of sludge. 0.58 mg per liter of sludge as CaCO3. 0.58 mg per liter of sludge as MgOH twice. Sorry, MgOH twice. MgOH twice. 1 mg per liter of added lime, whatever the lime we are adding, 1 mg per liter of added lime, whatever the lime we are adding, 1 mg per liter of added lime as CaCO3 produces 1 mg per liter of sludge as CaCO3. 1 mg per liter of sludge as CaCO3. So total dry sludge produced, whatever the dry sludge, so total dry sludge produced in mg per liter. Total dry sludge produced in mg per liter is equal to calcium. How much calcium is removed? Calcium removed plus 0.58 times of magnesium removed and 1 lime added plus lime added. So this is the total dry sludge produced in mg per liter. Total dry sludge produced in mg per liter. Okay, so this is the total dry sludge, and we will discuss a little bit left in lime soda method. We will discuss that, and then we will discuss the rest of the methods of demineralization and ion exchange, and then we will complete this topic also. So we are done with the treatment part. Once after one lecture, we will be done with the treatment part. We are going to solve the questions of the previous GATE examination. Okay, thank you.